So thanks very much, Rafal, and thanks all of you for coming. Nice to meet you all. So my name's David Hardcastle. As Rafal said, I run a team in Cambridge, which is responsible for question answering on Alexa. I'm also the site leader for Cambridge in the UK. So let me tell you a little bit about Cambridge first, and I'm going to tell you a little bit about what my team does, talk to you a little bit about question answering and why that's difficult when we're running at scale, and a little bit also how we get invention going in a large team in a commercial context. So Cambridge is a great site to work in. There's a lot of different teams there. There are various different Alexa teams working on speech, speech recognition, text-to-speech. Some of Rafal's team are there in Cambridge with us. My team working on question answering, people working on building a personality for Alexa, so lots of different Alexa teams. We have a team called Prime Air in Cambridge, which you may have heard of. They're responsible for doing delivery by drone. So we have some customers who, if they need a tube of toothpaste, they can order it and a drone will fly it to their house and deliver it to them. We have a team called Lab 126, which is Amazon's global team that does innovation in hardware. Some of them are in Cambridge. And our core machine learning team are in Cambridge as well. Core Machine Learning's job is to transfer knowledge and technology between different bits of Amazon that are using machine learning to solve very different sorts of problems. So it's a great office to work in. Lots of people working on hard problems, very interesting spaces, and great to be all under one roof. So I'm going to talk a little bit about what my team does on Alexa today. So I'll aim to talk to until about 10 to 1 and then maybe take some questions before the next break. So hopefully you've all heard of Alexa. If you hadn't before today, I think you have by now. So I won't tell you all about what Alexa is, but I'll tell you a bit about what my team does there. So the role of my team is to do question answering. And what we mean by that is providing information that customers need. Some of that information might be the same over time, like how tall is Mount Everest, or what's the tallest mountain in the world. That hopefully doesn't change terribly often. Some of it might be quite real-time information, like what's the latest score in the Chelsea game, for example. We get lots of questions from customers asking us about sports results, for example, and it's no good having static information about that kind of stuff. You don't want to know about it the next day. Also, we want to be able to work with a whole range of different information sources, some of which are in our knowledge graph, which I'll tell you about later, and some of which reside elsewhere. So someone might want to know, Alexa, will it rain this afternoon, for example? And again, that's also now not just time variant, but also, hopefully, we give a different answer depending on where you are. So question answering starts to become more interesting when you can sort of start from that sense of some canonical information around the world, what's in the public domain. And then you've got all these different sort of dimensions of interest, information that changes over time, where the sort of liveness of the information is really important, information that's different in different localities, different places. What about information that's of interest specifically to me as well? How context aware does Alexa need to be in order to give you the right information given a particular place and a particular time? And also some of the information about you and what you're interested in. So I'll cover that to some extent as well. So when I first started in 2014 working for Amazon, we were working on this question answering. We hadn't launched Echo or Alexa at that point. So most people I met within Amazon were pretty puzzled as to why there'd be a team in Cambridge working on question answering, because they couldn't see what that would have to do with anything that Amazon does. Once we launched Echo, late 2014, we launched last year in UK and Germany as well. So that's really brought us to attention, and it's really changed the nature of what my team does. So prior to Amazon, Evie was a startup. We had a little app. We had some users. They asked us some questions. But it wasn't the kind of thing where if we gave the wrong answer or said something embarrassing or the system went down, it wouldn't generate news in the way that it might do if my team managed to stop Alexa from working. So that brings that kind of scale and level of interest, brings some really interesting challenges. And I spoke to you, just now about, you've got to think about those different dimensions within question answering. So you've not just got a little progression suite that you're trying to get better at. Things are changing all the time. But also there's some stuff that you just have to get right. So there's some questions that it's embarrassing if Alexa doesn't know, right? There's some stuff that we need to fix. And there's also questions, there's some stuff that you just don't want to say as well, right? So, you take, somebody asks us a question about, is the Holocaust a hoax, for example? I don't want some greedy statistical algorithm or some stochastic process to suddenly churn up a surprising answer to that, right? I want to be really confident that that's not going to happen. And similarly, if somebody asks me, I don't know, who's the President of the United States? I don't want Alexa to say she doesn't know, because I've built some machine learning system that's got a reasonably high level of precision, but it's got some really rough edges that I don't have control over. So one of the real challenges for us working with this kind of stuff at scale is that you need a system that is super adaptable and works across lots of different people, lots of different dimensions. So technology like machine learning and stochastic systems are super useful for that. But I want really fine-grained control. And I'm not the only one within Amazon who wants to be fairly confident about what Alexa can do, and also some of the things that she won't do. What are the sort of pitfalls that she won't step into? So trying to balance those things out is an interesting challenge as we get more scale in a system that has so many customers and so much visibility. And I hope you're all aware of all our cool new products that we launched this week. So here are some of them behind me. I think one of the things I want to call out about the product set, and also especially if you think about things like the Alexa voice service that Max was talking about before, where we're really keen to see third parties, so other developers outside Amazon, come and build their own solutions, their own really exciting ways of bringing Alexa to life in different sorts of products and different contexts. What that means for us is that it builds, a little bit more multimodal experience. It brings Alexa into different contexts. And although it might not be immediately obvious how that impacts my team in Cambridge and the work that we do on question answering, it adds more of these different dimensions to the space that we're trying to cover. All right, so when we first launched, we launched with Amazon Echo, and I haven't managed to put the original Echo on my slide. I forgot to do that, but for those of you who wear it, looks pretty much like that can-shaped one in the middle at the bottom, and it came in, as Henry Ford said, any color you like as long as it's black, right? That's how we started out. And it didn't have a screen on it, which was pretty revolutionary at the time. Lots of people were a little bit surprised that we built something without a screen, and they wondered if it would even work. But it was a great risky, but the right thing to do because it really helped people to see what we were trying to achieve. We weren't trying to put voice in addition to something that you're really interacting with key presses or fingers on the screen. It's voice first, and having made that voice first market come to life with Echo, we've then augmented that in other ways, and now you can talk to Alexa on a car dashboard perhaps next year if BMW or Ford have shown us things at various trade shows that they're interested in doing. You could be talking to an intelligent fridge or a smart radio or a speaker system. You could be on a tablet. You could be on one of our new devices like Spot or Show that has a screen. So it's still voice-led, but you've got all these other different augmentations. And for us in question answering, that's a really interesting extension to the space, partly because you now might have some genuinely multimodal interactions, and as we get more of these devices into customers, there's a new area for us to really learn about. So rather than people just saying, where you've got these sort of co-references like saying, well, who's the President of the United States, and then something like how old is he, and he refers back to that individual. If I'm looking at a screen, maybe I should be able to say, what's that? All right, how do we cope with that? Or how tall is that? Or who's that person? So all sorts of really fascinating and super hard use cases start to spring to mind once you have this mixed modality that is increasingly present in Alexa. So that gives us a really fascinating research space to step into. And of course, as I'm sure you're aware, as Alexa comes onto more and more different devices, Alexa is moving into different spaces. So the original Echo was, it's a smart speaker. It's something that you listen to music on. The Echo Spot there has got a clock on it. I might want to have that on the bedside table. It's sort of replacing my alarm clock. So the kind of field of expectation in terms of the sort of topics I'm going to talk to Alexa about might rather change. And if I think about Echo Dot, the little small one there, we released Alexa then at a super low price point. So that's great. That really makes Alexa available to a much broader set of people than the first device that we put out there, but it immediately changed the kinds of things that people ask us. Because answering questions isn't just about having clever language technology. You've actually got to go and find sources of information in the world to be able to have Alexa know about the stuff that people are interested in. So if we look behind all of the different things that we had to do, when we first launched Echo, lots of the technology that we needed to launch Echo just didn't exist. It didn't exist at the level that we needed it to in order to launch that as a commercial product. So we had to go and invent an awful lot of things in the run-up to that launch. And we're still inventing. We're still working on Alexa. We want to make Alexa smarter every day. And some of that comes in continuous iteration, acquiring new data and training models and so on. And some of that has to come in big steps forward, where we've got to keep thinking about how we're disruptive with our own technology. It's not, we can't just sit back on our heels, congratulate ourselves about all our Alexa customers and decide that's job done and we'll just kind of leave it ticking over. There's plenty of more stuff to do and new places to get into. So we're still working super hard on lots of very interesting challenges here in Gdansk, in my office in Cambridge, and in other places where we're working on Alexa around the world. So I'm going to tell you a little bit over the next few slides about why I think answering questions is hard. You may disagree, maybe you've had a go at it. I'll talk about some of the dimensions, some of the challenges that my team is involved in. The next few slides don't represent all of what we do. There's a ton of different things that we're working on, but I picked out 2 or 3 different areas that we're currently investing in, so I can give you, I hope, a flavor of some of the sorts of things that my team works on. So here's an example of a question. So is the gherkin taller than the shard? So it's a little bit London-centric, so I perhaps should have picked an example that's more familiar to you. So the shard is that big, tall, pointy glass building on the right-hand side, and the gherkin is quite hard to see, but it's the sort of round, stripy building on the left. Right? So the user's intention is to find out between those 2 fairly famous landmarks in London which is the tallest. And to us, it's a pretty simple process, right? And even if you think through, if I asked any of you that, you'd have to go and find out what the height of those 2 buildings is, compare them, figure out which is the higher number out of the 2 of them, and then find some way of explaining that back to me and telling me why you thought that. And that's what Alexa is doing in order to answer the question. Now, in order to be able to get there, we've got quite a few, again, seemingly easy, but actually quite difficult things that we've got to be able to figure out. So taller could mean a few different things. That doesn't seem immediately obvious. Taller is just about height. But when you've got quite a lot of fine-grained knowledge, height can be different things. Lots of objects have a height, but many objects don't have a height that people really care about. So gherkins have a height, depending on which way you stand them and whether you can stop them falling over on the table. But it's probably even very interesting, and most people don't ask about the height of vegetables, right? So how does the system know that, right? Does someone have to go and enter all that information in? Think about all the millions and millions of things that Alexa needs to know about. We can't go through every single one, building these kind of rules for common sense. Otherwise, it would take us years and years, and my team would have to be much bigger than it is today in order for us to get anywhere. So Alexa's got to figure some of that sort of common sense stuff out for herself, right? And also, once we've figured out the kinds of things that you're likely to have been thinking about when you said taller, then we've got to go and figure out what the gherkin and the shard are, and that might depend a little bit on where you live, what your interests are. But also, what are the kinds of things that people care about? What are the gherkins and shards that everybody's talking about? And do we know about them? So it's a combinatorial space. There are lots of different hypotheses that we can have. And someone mentioned in one of the earlier talks about how important it is for these systems to be low latency. So we could come up with some great ways of solving this problem in an hour or so. And then we'd probably get really great precision and really great recall. How can we solve it in a fraction of a second and get it right enough of the time that our customers want to carry on using Alexa tomorrow, right? And the next day. So that becomes a hard problem to solve those combinatorics inside that short period of time. And also, of course, don't forget we've got ASR, we've got automatic speech recognition in front of us. Alexa isn't a system you type into, Alexa's a system you talk to. And Amazon ASR is fantastic, but also Alexa is designed to inhabit noisy spaces, like my kitchen at home. My children are tearing around, screaming at each other, and I'm trying to find out whether the shard is taller than the gherkin, right? And I really want Alexa to get that right. Excuse me. So maybe this is what I said, but actually what I'm going to get from ASR is like an NBEST list of transcriptions, and this might be on the list, but it might be not at the top. So that adds another area where we need that sort of common sense reasoning, because there might be a bunch of things that sound like gherkins and sound like shard, or even sound like taller. And from all of this sort of matrix of different possibilities, we've got to quickly pick the one that's most likely to match what you said. And then hopefully go and find the answer in the graph. So the graph looks a little like this, but you'll be pleased to know it's a little bit bigger. Imagine like a galaxy, and all the stars in the galaxy are things in the world that I hope you care about, that we know about: people, places, points of interest, and so on. And unlike my rather poor drawing here, I don't do anything to do with GUI or graphics at Amazon, you'll be pleased to know, but our graph is hyper-connected. There are lots and lots of relationships. They're not just single lines that connect the entities. So if we took something like Paris in France, for example, that would be one of the little nodes in our graph, and there'd be tons and tons of connections between Paris. Paris has a mayor. That mayor perhaps has personal relationships. The mayor has a height. They could be taller or shorter than the shard or the gherkin, right? They have maybe a date of birth. Paris has a population. There are lots of things in it. It's in France, but it also has a relationship to France, that it's the capital, and so on. And in the graph, there are tons of things that are called Paris, and some of them are going to be quite famous things like Paris, France, or Paris in Texas, or Paris Hilton. And some of them might not be famous at all. They might be the restaurant round the corner that's called Paris. So if I say how many people are in Paris, I don't want to know how many people are eating chips just down the road. I probably mean the really big city, right? So one of the challenges that we have is that, as I mentioned before, some of the information, like the height of Mount Everest, we can sort of get it right, and then we can relax. That's going to stay right for ages, I hope, unless something really calamitous happens. But most of the information that we have in the graph is changing all the time, and Alexa is going to give you information that's interesting if it's recent and useful. So that means that we have to be constantly going outside our system and finding information, right? Finding information that's in publicly available sources, or finding information where we've got licensing with third parties and we're able to pull data from those third parties and get it into our graph. But it's not all nicely organized in the way that we'd like it to be. So some of those different sources of information have got different structures. They represent knowledge in different ways than we do. So for example, if I get information about discography, about musicians and their albums from a music specialist, then if I ask a question like, how many albums did Motorhead do, for example, there's probably dozens and dozens, well, there are dozens and dozens, but there are even bigger dozens and dozens if I ask a music specialist, because the relationship between the musician and the album, there are lots of different cuts of the album, there are different versions in different markets, they have digital rights. But I don't care about that. If I'm asking Alexa, I want an answer where, for me, an album is a sort of thing that's got a set of songs and a name, right? And so you've got these different kind of mental models. If I was a real music aficionado, maybe I'm interested in actually thinking about all the different bootlegs. And if I'm trying to play an album at a particular point in time, then I need to know whether you've got the rights to listen to it or not, so I need all that other information. So even fairly simple pieces of information can be organized using very different knowledge representations, different structures, different arity relationships between entities and attributes and so on. So somehow we need to resolve all that to get the entity information into the graph and keep updating it. Plus, we have lots of other complex problems to solve. For example, if we were adding some new information and it told us there was a city called Paris that had a population of 100,000, does that mean that that's the population of the Paris in France that we were just talking about, or is that one of the other Parises that we know about? Or is that a whole new Paris that we didn't know about until today? And we have to get that right, because if we keep getting that wrong and we keep creating new entities, which is the kind of safe thing to do, then we won't be hyper-connected anymore. And if we're not hyper-connected, we can't use the information that we have about different things in the graph to do all that common sense reasoning, so we'll start picking the wrong thing. But on the other hand, if we keep fusing stuff together incorrectly, then we'll start assigning incorrect attributes to stuff that we know about, and then all sorts of crazy stuff will go wrong. And just like with what I was saying earlier about scale, we can't do this by hand. So years ago, Evie used to do a lot of this by hand because we were a small startup and we curated information into our graph with a huge amount of manual effort. But we can't build a product like Alexa that way. So we have to build machine processes that have super high precision that can make these decisions and get them right and figure out when are two things the same and when are they different, often based on quite small amounts of information. So another thing that we're working on is about asking this question: how can Alexa learn by reading? So it's great to be able to bring information into the graph from structured sources of information from other catalogs, but that's only going to get us so far, right? That's not how we learn. I don't learn by going and reading kind of, tables and databases and spreadsheets and things. I read books, I watch TV, listen to the radio. That's where I get lots of my information and knowledge about the world from. But I need to be really good at parsing natural language in order to be able to do that. And I have this same entity resolution problem that I need to know what this TV program or book or whatever I'm reading, I need to know what it's really about. Otherwise, I can't assimilate that information with what else I know. So this is a super hard problem. It's one that this is a research problem for us that we're still working on. We have some systems that do this automatically, but we've still got quite a long way to go. Years ago, before we were acquired by Amazon, we ran some experiments on having the Evie system learn by reading. And one of those experiments concluded that the USA was made of mayonnaise. We decided that's probably a sign that it wasn't working terribly well. So that's not the kind of stuff that I want Alexa to be thinking. And getting the precision high is actually really hard because taking text and turning it into facts is it's an attritional pipeline. So you've got lots of different problems to solve, and each of them has less than 100% precision, but they all kind of multiply out. So if you think about taking a piece of text and it says something like Michael is 38, for example, you've got to figure out who Michael is, right? If the title of the page is about Michael Jackson, maybe it's Michael Jackson, but maybe halfway down we started talking about his friend Michael, and that's the Michael that we're now talking about. Or maybe this is a page about an NFL roster, and 38 means the number on the player's back. It doesn't mean this person's 38 years old. So in language we have lots of ellipsis. We don't tend to always express stuff fully. We like to use shorthands for things, and we understand that because we're sharp at understanding context and figuring out co-reference and all these things, but we don't have systems today that can do that at 100% precision. So getting facts from text is important for us. It's a great way for us to scale, but it's a really hard problem space. And something else that I wanted to share with you, which this is one of the things why moving into lots of different marketplaces, moving into lots of different customer segments, working on different devices is so challenging, that's that there are lots of different ways to say the same thing in natural language. And part of the point of Alexa is that she doesn't have an instruction manual, right? And I know people do occasionally write instruction manuals for Alexa, but when they do, they're kind of missing the point of what we're trying to build. So I always find it a little bit disappointing if I see that someone's produced a, how to use Alexa book, because the whole point of what we're trying to build is that we don't need such a thing, right? You say what you want, you just ask, and Alexa understands, right? That's what we're trying to build. That's the Star Trek computer vision that we have for Alexa. So for that to work, we have to be able to understand lots and lots of different natural ways of asking about the same thing. And that's another very hard problem. And you can get a certain way by having lots and lots of data, but of course gathering data and annotating it is expensive, so that doesn't always scale. And if you think about the space of question answering, it's a little bit different from some of the other things within Alexa, that there's only so many ways I can ask to play a particular music album or a particular music track. But if you think about all the different facts that you might want to know about and all the different ways you can ask about them, especially when we try and work with Alexa to make Alexa more conversational, and we bring in anaphora and co-reference and so on, we were sort of trying to build that more natural set of interfaces, then you have a sort of almost infinite space of different ways that people can ask about even a finite set of things. So that becomes super interesting. And like I said at the start as well, it's really important to us with all of these problem spaces to think about hybridization. There's no magic bullet answer that's just going to solve this once and for all. And that's something that, I hear quite a lot about within my team. Lots of people, individuals in my team will say, oh, well, the answer to this problem is we'll just build an RNN, or we'll just do this technique, or we'll build that technique. All those, there are lots of different ways of getting a machine readable understanding of a piece of text, but none of them get us the whole way. And part of that's because it's not just an academic exercise. We're not just taking these inputs and trying to maximize our F measure or some other metric. We're also, like I said at the beginning, we're interested in having fine control in certain areas. So if I say something like play Adele, I pretty much 100% of the time want Alexa to play music by Adele. I don't want sometimes some stochastic system to find some little-known playwright called Adele and tell me all the names of the plays that Adele wrote, right? I just want to listen to music, and that has to work every single time, right? Nearly every single time isn't enough. So got some really interesting challenges there where I want to build really, really greedy systems sometimes because I want to be able to capture lots and lots of different modes of expression, but I also need to build super high precision into everything I do, otherwise I don't have a commercial product. So those kind of tensions start to become really interesting in this space. And one of the most important ways in which we defeat those tensions is by building a hybrid system, so using lots of different techniques. And of course, what that does is it gives us a brand new problem that we didn't have before, which is that often multiple techniques think they've got the answer. So we can ask all these different techniques, and several of them raise their hand and say, yeah, I've got the interpretation, and now we have a ranking problem, right? So now we have to figure out, for a given question and a whole set of answers that could be the best answer or the best interpretation, which is best, right? And now you can start to see the complexity of building this stuff out at scale, that the ASR team also have a ranking problem because they've got all these different theories about how to turn your speech into text, and I'm then got lots of different rankings in terms of how I've got different interpretations or understanding of that text. And then if I run my understandings against lots of different systems that are going to go and find the answer, then I've got another. So I've got this kind of fan-out ranking problem that I'm trying to solve in real time, and I still want to answer your question in a fraction of a second. That starts to bring an awful lot of different dynamics into play at the same time. And I think that piece around ranking then starts to become, as in many fields at the moment, it becomes super important for us. Let me just do a quick time check, see how we're going. Cool. So I wanted to talk to you briefly before I disappear about enabling invention. So my team in Cambridge, one of the things that I really want my team to be able to do, like I said earlier on, is invent. So making Alexa smarter every day is not just about iteration in little small steps. That's part of part of what we do. If you take something like our growth in terms of the amount of volume that we can take, great. There's some really valuable operational work that we can do to just make our systems leaner and leaner and faster over time. But some of the sort of problems that I told you about, they require more disruptive change. So we need invention. And we have a bunch of different ways in which we take teams within Amazon and we try and help those teams invent in these really hard spaces where we're working in a commercial environment. So sorry, there's a bit of text on the screen here, which is unusual for me. But so first thing is about working backwards from customers. So our aim in Amazon is to be Earth's most customer-centric company. We work backwards from customers. So invention for us isn't something that happens in isolation. Invention is connected to customers, and I think that's a really important thing. And actually, when I interview people who are interested in joining in Cambridge, one of the things that really resonates for them often, depending on where they work, is exactly that notion of building these cross-functional teams where you've got a group of people who are trying to invent on behalf of customers, rather than disparate teams, some of whom are inventing, some of whom are thinking about product, some of whom are responsible for building in production. All right? And a lot of companies that my friends work in or where I've worked in the past, you've got these kind of silos where you've got a lab with all your scientists and they're responsible for invention as though invention is some kind of commodity that they can sort of, push out these occasional invention ideas. And then the next silo is you've got all your people who productionize these inventions, which one of my least favorite words. I think production, every time I hear productionize, that's a really bad smell. That suggests something's gone horribly wrong with someone's idea of how to organize an inventive company. Because of course what's happening is the scientists and the inventors have lost control of how they're going to get this stuff into production. But also, if you build something and you weren't thinking about scale when you were first inventing, maybe you didn't think about the full space that you're trying to invent into. Sometimes these challenges of scale are super important. Sometimes thinking about, well, how do I make this work for millions rather than just tens of people, or for billions of utterances rather than this sample set I've got, makes me think in a different way. And I think what I see go wrong elsewhere sometimes is that productionization step basically just means starting again, right? So the production engineers say, well, the scientists have written this kind of slightly crummy Python script, and that's interesting, but we kind of get what they're trying to do, and we're just going to go and invent the whole thing from scratch in Java or C++, right? And now I've lost all of that transition. And then the third people that I have is the product people, and they come along right at the end when everybody else thinks they've finished and say, oh, finally, you guys have built something. Let's see, oh, that doesn't really fit. I don't think our customers really want that. Let's can it or shelve it or go and change it and start the whole process again. Well, that's not how we work in Amazon. We work with cross-functional teams who have ownership of a problem space. So if we're working on a problem space within question answering, like, for example, trying to get facts from text for our customers, then I want to take the people who are going to make that run at scale, the people who really understand NLP and fact extraction, and people who've got an understanding about the product and the type of stuff that we're after and where we should put our efforts. And let's just go and build that group as a single system, and they're going to go attack that space as a team. And no one gets left out then where we get to production, because we start in production. All right? I think that's the thing I find most exciting about working at Amazon is production doesn't come later. That's where we live every day, and it's where we invent, it's where we test, it's where we try stuff out. There are no little labs tucked away in the back room. Production is just where everything happens. And as I mentioned on the screen, I put a few, thought points up there. It's not easy. It's easy for me to say, oh yeah, cross-functional teams, that works, but cross-functional teams are hard, right? Typically in Amazon we have what we call 2 pizza teams, so a team of people who could eat a couple of pizzas if they sat down for lunch, right? So depending on your appetite, that's going to be sort of 5, 6, maybe 8 people, right? So if you have a team like that, and you've got some product people, and you've got some scientists, and a couple of NLP experts, and some engineers, what you can quickly see is that it's very hard if you're one of those people. Where does your career progression come from? Who's the kind of real expert in your functional domain who's sitting next to you that you're learning from? And who's giving you the expert review, right? And how does your manager know about all the things that you want them to know about, so they really understand what makes you an expert in your domain? So cross-functional teams are difficult from that side. So as a people manager, you've got to put other systems in place. You've got to run guilds, you've got to have regular workshops, you've got to do mentoring and peering, you've got to connect those teams back together again, because you need to create those functional disciplines if you want to hire expert people and give them really great careers, as well as creating these nice agile teams that have a single focus on the customer. Now this is a Christmas tree made out of asterisks, and it's very relevant to what I'm talking about, because 20-odd years ago, when I did C as a student, this was the sort of exercise that you had to do in C, right? You'd build a few for loops, and you'd print out some asterisks that were shaped like a Christmas tree or a diamond, and it was very exciting. And you didn't have very much in the way of library support. And then if you got really great at C, you could do like a student project that maybe had a set of grades for students and some kind of document store or something, and you'd spend ages and ages getting on and doing that. And the reason this is relevant is because I think that, if you look at students today, I did some like marking student projects with Cambridge University recently, and they didn't do this kind of stuff, right? They did cool social media applications that had facial recognition or a 3D racing game, and this kind of stuff. And the reason they could do that is because the stuff that they're standing on is they're such bigger blocks, right? They're picking commoditized pieces of software and cleverness that operate at a much bigger scale and solve a much larger set of problems, and they're gluing them together to go and invent and do some really, really cool stuff, right? And so I think that's all, that's obvious that nowadays we can put bigger blocks together. What I really want you guys to think about, because it's super relevant for me and my team, and that notion of inventing in production, is that one of the things that we can forget about is actually all of the building blocks that get you in production and allow you to exist in production. You can, even with those building blocks where you've got NLP toolkits, and you've got ready to roll graph implementations and databases and so on, you can go and build a great system But if you want to run it at scale, you still have to have things that run your fleet and all the thousands of machines that you've got running around the world, and you've got to be able to turn things on and off in different regions. You've got to have a whole bunch of test and launch and that kind of infrastructure metrics and so on. So being able to commoditize that kind of stuff, I think that's for me where things really start to get exciting in terms of invention. Because if you go back to what I was saying before, where you've got your poor inventors and scientists who are being asked to kind of commoditize the invention process, and they're sort of producing these kind of pieces of invention for other people to go and take to production, that's upside down, right? We don't want that. What we want to commoditize is the production environment. Right? That's the commodity I want to stand on top of, is a high-scale production environment that's got millions of active customers. And then the invention is happening on top of that. So if we can build on top of tools that actually allow us to operate in production all the time, and production isn't a kind of specialist, scary place, then I can iterate at a much faster rate. And of course, if I'm a company like Amazon and I'm customer-driven, that then makes complete sense, because it doesn't make sense to innovate anywhere other than production, because the very first thing that I really want to know is what do customers think. Because if I'm not asking that all the time, then I'm going to find out too late, right? And then I'm inventing the wrong stuff. How are we doing for time? Oh, blimey, wrap up fairly fast. So 2 other quick things I wanted to talk about. Diversity. So here's a quote from Jeff. Let me read that out to you from my screen. We're a company of builders whose diverse backgrounds, ideas, and points of view are critical to helping us invent on behalf of all our customers. But it's not only that diversity and inclusion are good for business, it's more fundamental than that. It's simply right. These are enduring values for us, and nothing will change that. And I want to unpack that a little bit for you, because I think there are 2 really important points here. So one is that if I'm going to have a team that's going to invent, and they're going to invent in a global, high-scale environment for a very diverse range of customers across a hugely diverse range of technologies and contexts, then I want my team to have diversity in it, right? Because that's where that diversity of thought and diversity of perspective helps us invent in different ways. Diverse teams, again, like cross-functional teams, doesn't come for free. If I want to move really fast in the short term, then I want a group of very, very similar, very, very like-minded people who never disagree with each other, and we can just go and build something. That's great. But if I want to build something for the long term at real scale, I need a diverse team whose diverse perspectives will lead them to challenge each other and come up with stronger and better ideas that are more lasting. So that's difficult to build, and that's where the other piece of this statement is so important, that diversity requires effort. Right? You've got to think about biases within your team, you've got to think about biases within your process, and that requires some culture in your company, right? Your company's got to really believe in the value of diversity, and it can't believe in it just as a kind of side benefit for business, right? You can't just say, oh, well, diversity, yeah, it kind of helps innovation, so we'll kind of do it when we can. That's never going to get you anywhere, because actually there are quite a lot of challenges that we have in the software industry in order to get more diverse and have a more diverse range of backgrounds and experience that we bring to bear in our teams. So having that kind of top-down commitment in your company to diversity, not just being something that's a nice to have, but being fundamental to the identity of the business, super important. And that liberates me. In Cambridge, we have a diversity working group. We treat that as a team. It has a whole backlog of actionable outcomes that we're doing and measurements that we're taking to really check that diversity working group isn't just a talking shop, but it's really having impact. That culture allows us to do that. It gives us traction within the organization, and it gives us focus. And the last point I wanted to call out about innovation and invention is about metrics, and that might sound a million miles away from invention and might have associations of operations and operational excellence, but it's actually really crucial to the kind of inventive cycles that I've been talking about, because you don't know if you're succeeding if you can't see what you're doing. And just like if you're going to run a really big system, you need fantastic operational metrics, because if my system goes down, I want to know within at most minutes that something's gone wrong with it, and I want, within a small number of minutes, I want people to have been paged and they're fixing it, so I can fix it before customers find out about it or before too many customers are impacted by it. And similarly, if I'm inventing in production, as well as the operational metrics, I need tons of really great product and performance metrics. So if I've got some really great new idea that I think customers are going to love, I want to find out as close to real time as I possibly can whether they actually love it or whether they hate it. Because if they hate it, then I'm getting something wrong and I'm misunderstanding them and I'm inventing in the wrong way. So just like you want to commoditize that process of being in production, being able to see what you're doing, being able to see those customers, and if you've got tens or hundreds of millions of customers around the globe, then they're quite hard to see, weirdly. The more there are, the harder they are to see. It's easy if you've just got 30 or 40 customers, I can just keep going and asking, right? So metrics, super important part of invention as well. So that's me. I shall hand back to Rafal and let him get some questions. Thank you very much.
Thanks, David. So we are open for questions, so I'll move a bit back to also allow you to ask.
Hello. So I had a question regarding the answers that Alexa gives to people. So where do you assume that I ask a question like, who's the president of Brazil? So where does the Alexa get information? Do you scrape the web, or do you have some dedicated sites like Wikipedia or anything else?
Yeah, it's a good question. So we don't just scrape the web. We have a mixture of, we have some public sources of information, but we also have some licensing agreements with particular third parties. I think the most important thing to get our information from is that it's a curated set of trusted information. So we've got to be really careful about our sources. And sometimes I find it super frustrating every day that we don't answer all our customers' questions. I'd love to do that. There's always some that we can't get to and we don't have the information. And it's always super tempting to just cast the net really wide. But I think one of the things that's important about Alexa is that notion of trust, that the knowledge that she has, we've worked hard to make sure that it comes from the right places and that we've verified not just the veracity of it, but also the authenticity of the source. So yeah, so it's a mixture. And it's a constant tension. You know, there's that sort of coverage precision piece that you have in NLP. To some extent, we have that with our data. So how flexible should we be about just crawling the web a little bit more versus trying to maintain that position that we're a trusted source of really good quality information that we're prepared to pay to go and get it. Thanks.
Other questions? Okay. That's a kind of puzzle.
Okay, so is there any scenario when Alexa would refuse to provide an answer to customer? And if so, how it would decide that? Intentionally?
So not currently. We do have some questions where I don't want to let the automated machinery answer the question, but I don't want a situation where Alexa is just deliberately silent. I think we have a team actually outside of my team that is specifically interested in sort of sensitive topics. And they're closely connected with the team that also works on Alexa personality. And so that goes to that piece I was talking about before, where however hard you drive to go and build these kind of self-measuring and automated systems, there are still some sorts of things where I think it'd be, it's kind of irresponsible in some ways if you just let that run wild, right? You have a duty of care almost to make sure that you're really thoughtful about those kinds of questions that could offend or upset some of your customers. And how you handle those. So there are some questions that we try and handle in a particular way, and some of those, we have a system that allows us to hand curate answers, and sometimes that's kind of useful. And we use it as well for what we call phatic. So if you say to Alexa something like, tell me a joke, she doesn't invent her own jokes off the knowledge graph. So if you thought that, I'm sorry to disappoint you. There are some people writing them. And similarly, if you say things like, Alexa, thanks very much, or will you marry me, or that kind of stuff, then there's people writing some of that stuff. So we can use those same technologies and techniques to deal with questions where we don't just want to let the machine system go off and figure it out for itself, especially with respect to that earlier question about, I don't want to just go and pull it from any old place on the internet that I can find an answer. I want to actually be a little bit more thoughtful. Thanks.
Okay, so how would you solve this problem you were just talking about when you enter some special kind of markets, areas like China, for instance? I think, this is the question.
What do you mean?
I mean, using sources of information, yeah? Because in some parts of the world, this is somehow different.
Yeah, that's a good question. So, I mean, I don't have a particular strategy for China, but certainly, right now we're in the US, the UK, and Germany. If we were to launch Alexa in other parts of the world, then that's something we're going to have to think about. I mean, our goal is always to be customer-centered. Our goal is to do the right thing for the customer. So, I think whenever if we're going to go into other markets, that's the attitude that we'll take with us when we go there. Is that we want to serve on the needs of our customers, and that's got to be the primary imperative. There are obviously going to be some challenges there. I know not every country we might take Alexa into would like us to answer every question that the citizens of that country might want to pose. So that'll challenge us when we get there, and we'll have to think very hard. But customer centrism will be a tenet that we take into that process.
Let's take the last one.
Hey, if you're working in a production environment, okay, and you've got hundreds of thousands of individual end users, how are you measuring satisfaction with answers? Are you waiting for that's good, or what?
Yes, a good question. So we have a few different techniques, and we have a bunch of stuff that we're working on to get better at it. So there's some stuff we can do where you can just take some raw measurements, where you've got sort of operational performance metrics, for example. So even just simple stuff like, did we actually provide an answer to the question, or did we come back with the dreaded, I'm sorry, I can't answer that right now. So how can we take those I'm sorry utterances? We can measure those in real time across the whole customer base as an output metric, and then we can set a whole bunch of targets to try and drive that down. So that's the easy bit. I think connecting, actually the next step is figuring out whether the answer was correct or not, right? So obviously we like to think that everything our system says is the best possible answer we could have given, but we score the answers that we give. So we have to do some hand annotation, and that obviously is quite expensive. And then you've got all sorts of questions around sampling error and so on. So, but we have a whole bunch of technology within the team that allows us to categorize questions by different areas of interest and different topics, because if we couldn't do that, we couldn't do some of the other stuff. So we can reuse some of that technology so that we can get sharper metrics out, so that we can get our sampling and make sure our sampling's got broad coverage, so that when you've got millions and millions of utterances, having even tens of thousands is quite a low sample error, so it's low sample rate. But if you're sure about the fact that you're spreading it across lots of different topics and different places and so on, then that can help. The other thing then that we're really interested in at Amazon is customer satisfaction. And that's a more challenging thing. And there we need to use a mix of different techniques where we do surveys and so on. We look at feedback. We collect some feedback from the system. We're getting better at that than we were when we were launched. So, quite often people express their displeasure with what Alexa has just said. Maybe we can pick up some of that and work on that and automate that. But we also do focus groups, and we do various actually even anthropological studies where we're just really sitting in and watching how people interact with the device and getting their feedback. So there's quite a lot of different things. I think just like with the question answering, you need lots of different tools. You can't just do the hard metrics, because you don't really know how they connect to actual customer satisfaction. But you also can't just do the soft metrics, because you don't have the sense of how applicable they are at scale. It is something we spend a lot of time thinking about. So we do obsess to a fair extent about all those different metrics and think about how the work that we've got in the backlog is actually going to move those different metrics in the right direction. Thanks.
Cool. Thank you, David. Thank you very much.
Cool. Thanks,
for your
Rafał.
presentation.